Section 1.7 is titled Function Notation. What we're going to do is, one, just go over what function notation is, and then look at how do we evaluate functions that are written in this function notation. Not really a whole lot new here in this lesson. It's mostly just a notation thing. How do we write and represent functions and then work problems in that? So kind of getting used to seeing the language, notation of functions. First example here we have says, consider the following function. I know it's a function because every x there has only one y value. Let's put these points on a graph. 1, 4, 3, 8, 4, 10. We can see that these points fall on a line. I do my best to connect them. And if I were to extend this, we can see that it is a function. It would pass a vertical line test. So the following function here, these points, and I'm kind of adding points to it on the graph, but these points, just part of the points on a function, model the line. The line can be modeled with an equation. We're going to go over this in chapter 2. I'm just going to give it to you now. Okay, so we've got an equation, a graph, set of points, all describing the same exact thing. Okay, this I know is a function because I can look at the x's and see they have only one y. Right? This I know is a function because I can see it passes a vertical line test. The question is, how do I know that this is a function? If I'm just given an equation, how do I know? Okay, well, that's where we're going to introduce function notation. It gives us a way to see equations as functions, and then we don't have to investigate with graphs and points if this is actually a function or not. So function notation, I'll say in an equation replaces the y with f of x if y is a function. Okay, this part right here you read as f of x. So the f indicating function of x, x is identifying here what the domain variable is, or what the independent variable is. So it's telling this is a function of x. Okay, so every time we see equations that have this instead of a y equals, we're guaranteed that we're looking at a function, essentially. So evaluating functions in function notation, we see here it says f of x equals 2x squared minus 3x. So we see this, we know that this is a function. Okay, we're asked to find f of negative 3. Notice that what I've done is I've replaced the x with negative 3. Okay, so what we're going to do is replace the x's here with negative 3. So if I want to find f of negative 3, it's 2 times negative 3 squared minus 3 times negative 3. Now we work order of operations. Power gets done first, that's 2 times 9. Negative 3 and negative 3 multiply to positive 9. So I'm going to multiply first, I get 18 plus 9, which is 27. So f of negative 3 is 27. And since this is a function, functions represent points. Okay, this is an ordered pair point. What this says is that when x is negative 3, y is 27, or what I've just located is the point negative 3, 27. Okay, if I were going to graph this, this is a point on that graph. Okay, just a few more examples is all the same thing. Evaluate f of 0, f of 1.5, and f of -4 for this function. So if I want f of 0, I'm putting 0 in for the x. 3 times 0 minus 4. So f of 0 is 0 minus 4. F of 0 equals -4. Please, as you're doing this work, if you can, especially on problems where you're doing multiple problems within the same function, continue this labeling, the f of 0 all the way through. Okay, I want f of 1.5 equals 3 times 1.5 minus 4. So f of 1.5 equals 3 times 1.5 is 4.5 minus 4. So f of 1.5 is 0.5, half. And finally, the last one of those, f of -4. So it's 3 times -4 minus 4. So multiply first, that's -12 minus 4, which is -16. Okay, let's do one more problem. This last problem, we're going to evaluate functions, but use a graph instead of an equation. And I've changed the problem a little bit, so on your notes, if you're taking notes at home, just scribble those out and use these numbers down here. They'll work out to better numbers, easier numbers to find on our graph is all. So f of -4. Well, since these represent points on the graph, all we need to do is locate the point where x is -4. Okay, so let's find -4 on the x-axis. It's right here. It actually hits the graph right there. That's a point. That order pair point is -4, comma 0. Next one, f of 8. So I go out to 8. 1, 2, 3, 4, 5, 6, 7, 8. Let's go up to our line. See right there. So what is that ordered pair point? It would be 8, comma, let's just call it 3. It's pretty close to 3. Last one, f of -1. So I go to -1 on my graph, find it on the line, it's right there. So what is that point? It's -1, comma, -2. Okay, so same exact idea as the last problem when we had an equation, just trying to cement the idea that function notation, we're finding points that would be on the graph is all.